So today our lecture could be on frame allocation. Next topic within our virtual memory shall be frame allocation. So what is the importance of a frame allocation for a particular job and how these are going to be done? So while any kind of virtual memory concept is being going on here. So for this, we'd like to take some frame allocation topic today. What is the importance of this particular topic here in the sense you can see. So totally by default, so we do have approximately 4096 frames will be there within one particular memory, so which is available for users memory, and these frames are supposed to be allocated to the particular processes where exactly existed here. Then for time being, we'd like to concentrate on minimum numbers. So minimum numbers will be, for example, 128 KB of the frame size will be 128 kilobytes. 108 kilobytes of memory will be there with you. So this is the memory where exactly you are having. And each page or each frame will be composed with 1 kilobyte. So therefore, we do have so 128 frames are available in our process in our system. So as we know, frame is physical memory, page is logical memory. Logical memory in the sense the CPU generated address will be always in terms of pages, whereas the physical memory always identifies frames only. So that is why page table is required between the physical memory reference and logical memory reference here. However, if this could be there here in the sense, for example, some 35 frames have been taken for 35 frames have been taken out of 128 taken by operating system. For example, remaining frames will be, for example, remaining frames will be 93 frames are free. While we have discussed something about page table, paging, we have given that some information has given that entire logical memory will be divided into several number of frames, and how many number of frames are required for a particular process, those many number of frames are supposed to be given by operating system as far as paging is concerned. Whereas in demand paging, so since the number of frames have been allocated to so different kinds of processes, obviously, so number of processes have not been allocated to the frames, so that throughput of that particular CPU will be gets reduced. Okay, for example, if a particular process will require some 25 frames in the sense, 25 frames will be allocated by paging. Some other process will require some 100 in the sense 100 will be allocated to the, so if the things will be existed, so 100 will be there with you, 100 will be allocated to the particular process so that it will be gets executed. Out of all these, 100 pages cannot be executed, 100 frames cannot be enforced while executing the things. Only one frame or two frames are being available with you with CPU while it is being generating the address and it is being executed. Remaining all are so under waste only. So they are just load the particular entire process into the backing storage device to physical memory, so that they will be so things will be that the page faults will not be existed. So that is why paging will be taken something like that. Because of this reason, throughput in the sense for an instance of time, number of jobs to be completed by CPU will be considered as throughput. For example, if you take 1 unit of time, so within 1 unit of time, how many jobs have been completed? So that number is called as throughput of the CPU. Within an instance of time, so this is the definition for throughput. Within an instance of time, how many number of jobs or processes have been completed is called as throughput. Throughput of CPU or microprocessor, whatever it means. So this is called as throughput here. Since number of jobs have been allocated, so if you want to make increase the throughput will be gets bigger enough, in the sense you have to load as many number of processes into the memory, use a number of processes into the memory. If huge number of processes are there with the memory, then obviously throughput of that particular system will be gets increased. But as far as spacing is concerned, how many number of frames are required? Those many number of frames have been allocated for a particular process, for a single process. So here, as far as our assumption, so here you can see you just have 93 pages are there with you. So for these 93 pages, let me say one particular process one will be required some 30 pages, process 2 will be required some 40 pages, process 3 will be required some 50 pages, something like this, and so on, blah 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 and so on. So you can able to allocate only these two processes, because remaining 23 pages are not enough for allocating this particular process here. So therefore, only two processes have been allocated its memory in physical memory, so that only two processes will be gets executed within the instance of time here. So within this particular instance of time, what is the throughput as far as this discussion will be just two, only two. Then if you restrict the number of allocated frames to a particular process, then it will be gets increased. It will be, throughput will be gets increased. So that is the actual idea behind this particular frame allocation. That is why frame allocation is required. Okay, throughput of your process will be, your CPU will be gets increased. So here, as far as virtual memory, demand pacing concept, you may be given only 3 pages or 4 pages or 6 pages, something like this, as far as our discussion, which was made in our previous classes. You have given. So we did some kind of applications as well. Algorithms as well. 3 frames will be there with you. What are the number of page faults, and 4 frames will be there, how the page faults will be so affected. All these things has been studied by us. Okay. Now the question is, in demand paging only, if number of frames will be gets available, how you can allocate these frames to the processes, available for processes? Is there any specific algorithm to be operated, or straight away operating system will decide? So this a kind of allocation will be done by processes or not? So operating system also a particular software which must be always run one particular kind of algorithm, so that it will be gets follow that particular algorithm only. Now, we'd like to see allocation of frames algorithms. So there are two different types of allocation of frame algorithms. Number one is equal allocation. Number two is proportional allocation. Equal. Number one is equal allocation. Number two is proportional allocation. Proportional allocation. So as the name suggests, whatever the name it has been given, as the name suggests, for example, so n number of processes are there. Let me consider as far as my example just before I have given to you. So this particular example has been taken. 93 frames are free here. As far as example I have given. So here 93 frames are there with you. Totally 93 frames are there with you, and you do have some 5 processes are there with you. Five processes are there with you. So how it's very simple, it's very simple to allocate for this particular kind of thing, the equal allocation. It's very simple. So number of frames will be 93, number of processes will be 5. We'll be taking, so 93 divided by 5 will be considered as equal allocation. So simple as that. So number of frames available, number of frames available divided by number of processes. Number of frames will be considered as m number of frames are there with you, and n number of processes are there with you. Then we'll say m divided by n will be the particular value. Let us examine how this could be. So let me open calc here for a while. 93 divided by 5, 93, so divided by 5 will be gives you 18.6. Okay, each will be taken, so 18 different kinds of processes. These 5 processes will be taken, so 5 processes, so which is 18.6. Okay, so these 18.6 are supposed to be allocated. So 0.6 could not be gets allocated here. Is 5 processes will be allocated 18 frames, and 18 into 5, let us see what is the particular value here. So 18 into 5 will be equal to 90, and remaining 3 will be goes for remaining 3 frames. 3 frames will be treated as so free frame pool. Free frame pool. This will be considered as free frame pool. They will be available with so free frame. Let me consider not free frame buffer pool. Buffer pool. So it will be considered as a free frame buffer pool. If any new process will becomes, then free frame buffer pool will be given to that particular process. Okay, something like this, which is going to be happen. This kind of activity, whatever the activity I have given here, this kind of activity will be called as so equal allocation. So total number of frames divided by total number of jobs or processes which are available within the ready queue. So that will be gets operated. Then obviously you could attain a floor value. So normally this will be always taken with the floor value here. This is floor value here. Floor value does means it will be taken 18.6 will be taken as 18 only. 0.6 will be gets so truncated. This 0.6 will be turns to 3. So here this is 3 actually. So this 18 will be gets allocated to all these 5 processes, so that you will be, so process will be, execution will be done here. Here in equal frame allocation, there is a problem. What is that particular problem? Let me discuss with that particular problem here. The problem is number 1. If you are trying to specify equal frame allocation, for example, process P1 So process P1 having 100 pages to be executed. 100 pages to be executed, and there is a particular frame reference string also be there while it is being talking. Okay, demand pacing always requires some page reference string must be required, sir. So first 0 can be started 2, then followed by 7, then followed by 5, then followed by and so on and so on and so on and so forth. Something like this, some reference string also be there. So as far as just before discussion, so m by n number of frames are, I mean, this particular thing. So m divided by n of floor number of frames are allocated here. Frames are allocated here. Allocated. Hence, number of page faults which are available could also be lower of m divided by n page faults. Because number of available frames are very high and the number of jobs are very low. So therefore, very high value divided by very low value will be results some a bigger value only. So process 1 does have 100 pages in the sense first 18 pages as far as our example just before what I have shown here, this particular value. So first 18 pages, it would be considered as page faults only. So 18 page faults are compulsory. Thereby you have to follow demand pacing. Thereby you have to follow demand pacing. Whatever the algorithm you are supposed to use, that must be followed. 18 page faults are mandatory. So this is the problem with the equal page allocation. Since this particular problem is there, so it will becomes with the proportional allocation. Understand? Proportional allocation. Do you have any questions here in terms of equal?
No, sir.
No?
No, sir.
Yeah. Okay. Vijay కూడా రాలేదు ఈరోజు. Okay. However, then proportional allocation. What do you mean by proportional allocation here? Proportional allocation. So the proportional allocation should be done something like this here. So this is always been concentrated on so how much amount of space is required to run the problem. Not exactly pages. How much amount of space is required to run the particular process. For example, a particular process might be having. So let me give you one particular formula, then I'll give you some example. Okay. So for example, a particular process must be required. A particular process must be required. So virtual memory which is required, which is available for a particular process will be SI. There is a process PI will be having SI as it's defined. I mean, virtual memory size will be required is SI. Therefore, total virtual memory which is available to allocate the particular process will be capital S will be equal to total in the sense where PI does means for all I must be equal to 1 is less than or equal to I is less than or equal to N. So therefore, N number of jobs are there. These N number of jobs, each job must be required. So small s of I. So let me eliminate this one for a while. Let me eliminate this one for a while because it is a small si. It is not capital Si, small si. It is a small si. Okay, that's what you need to. So that is why I'm eliminating. That's all. There is no other point I'd like to eliminate this one here. So okay. So this is something I have to write something like this. A small si. Okay. Therefore, each process must be required this much amount of space in the sense S will be equal to sigma. sigma I will be equal to 1 to n, so small si. This is the total amount of space you may be required. This is the total amount of space you may be required. Okay. Then let me consider one more consideration here. Total number of available frames. Number of available frames. Number of available frames will be equal to m, for example. Okay. Then, so operating system maybe allocates. Operating system maybe allocates ai number of frames to a process pi, to a process pi. Okay. Then for a particular process, it's been allocated something like that. Okay. Then what would be the so approximate allocation of approximate value of this particular thing, how much will be required of what is the actual value for this one here? So it would be seems something like this. So it could be gets occupied this much amount of these many number of frames are supposed to be gets allocated will be, so ai will be equal to si small si, sorry, small s suffix I divided by capital S into how much memory which will be how many number of frames which are available, so which is lower only, always it is lower only. This is lower value. Okay, this is lower value only. So in this way it is going to be allocated here. For example, so let us consider here, as far as our assumption, I would like to say some 93 frames are available. 93 frames are available for us as far as our previous assumption. Number of available frames which will be considered as you need this one. You need a equal to
Fine, sir. Capital S is equal to summation of 1 to
సో హియర్ అప్పుడే అడగాలి కదా, అంతా అయిపోయిన తర్వాత అడిగితే ఎలా కుదురుతుంది? సో పిఐ ఈస్ హ్యావింగ్ సో దిస్ మచ్ అమౌంట్ ఆఫ్ స్పేస్ required, this much amount of space. Okay, this is the amount of space which is required to allocate by pi. So that's what the meaning here. Okay, so pi is required some 1000 kilobytes, pi is required, p1 is required some 250 kilobytes, something like that. Okay, then so process 1 requires something, process 2 requires something, process 4 something like that. Please remember, please recall yourself in terms of contiguous space allocation. Thereby process 1 required this much kilobytes, process 2 required this much kilobytes, something like this. So capital S will be defined something like this as, so capital S could be taken, so totally how much amount of space is required, to allocate. So that is the meaning of this summation. So if you are supposed to say what is the total amount of this one, 350, 400 and 445k. 445k is the capital S. That is the meaning. Okay. Now,
okay, sir.
now, So if things will be seen something like this, number of frames available as far as our previous assumption, that is 93. So let me consider this is M will be equal to 93. Okay, 93. Okay, then total number of pages which are pages or sizes which are required, so let us consider, please let us consider SI must be this particular value. SI must be number of pages, or otherwise the size also be no problem. Either it is in terms of so pages or size of the process, anything is okay. Anything is okay. Okay, let us consider, if for our simplicity, we would like to consider number of pages instead of size, number of pages. So total number of pages will be capital S. Total number of pages will be capital S. Okay, total number of pages to be executed. Each page size will be, let us consider 1 kilobyte. Let us consider 1 kilobyte. So total number of pages will be capital S. Okay, please interpret something like that. Then we'll have some kind of clear idea what we are supposed to do. So there are certain number of what you call processes which are being executed. So of total size will be, so total size in terms of pages. Okay, let me write. I'm talking about only pages only. Total number of required pages. Total number of required pages will be equal to yes. Okay, will be equal to yes. And then actually, for a particular process, for a particular PI process, so PI required pages. So will be S suffix I. S suffix I. Then let us consider how the allocation could be done. Allocation could be done with this particular thing here. This is the AI will be equal to S suffix I divided by S into M. Now here, I'd like to consider here totally some two processes are there. So process P1 is required some 25 pages, and the process P2 is required some 140 pages. For example, this is lightweight process. So this is a lightweight process, and this is a heavyweight process. For example, heavyweight process. So proportionally, so here this may be required very less in number of frames, which may be allocated for 25. Actually, you need 25, but 25 cannot be allocated for you. 140 is required, but 140 cannot be allocated for you, because there is no those many number of M is not equal to so number of S here. So as far as this particular thing, capital S will be equal to 25 plus so 140 will be equal to 160. Okay. So we know SI. So each SI in the sense, so small S1 will be equal to 25, and then small S2 will be equal to 140. Now supply the same thing here. Supply. So allocated frames A1 will be equal to, what is the formula here? So SI divided by SI in the sense 25 divided by 160 into, so how many number of frames which are available? M will be 93. M will be 93, which will be approximately equal to, not exactly, approximately equal to. Let me open this this thing again. So look at this, 25 divided by 25 divided by, so how much it is? 160 will be equal to into 93. Approximately 14.5. Let me say that is 14. Let me say that is 14. Okay. Similarly, so second process will be taken here. So A2 will be allocated frames for one particular other process, that is 140 divided by 160 into 93. It is also approximately So will be equal to, look at this, 140 divided by 160 equal to into 93. Where is 3? 93. So 81, approximately 81 can be gets allocated. Understand? So this is proportional. Proportional will be done in such a way. So you can see previously, as far as so this particular allocation, equal allocation, every process will becomes some 5 processes are there. All these 5 processes will be attained at 18 pages. Now I have taken only 2 processes here. So one process has been allocated with 14 frames, and the second process will be allocated with 81 frames. Okay, so this is what about the what you call allocation of frames. Okay, frame allocation or allocation of frames. Now these allocations will be taken in what basis? In what basis it is going to be allocated? So obviously you do understand here, as far as this particular kind of allocation, for example, as far as this particular two processes, allocation A1 will be equal to 14 and A2 will be equal to 81. For this particular process, so 14 page faults will be, so page faults will be obvious, and here 81 page faults will be obvious. That's obvious here. There is no alternative to reduce the page faults. Okay. Now, so when page fault will be gets occurred, how this could be resolved? How the resolution can be gets happen? Are there any extra factors to be involved while page faults will be gets occurred here? So now global allocation and local allocation. There are 2 different types of. So I mean allocations will be happened with this one only. So equal allocation and proportional allocation only. There is no doubt on this particular thing. But where how the frames are being treated. So from global space or local space. So global space or local space. So for example, if you take a global space, all 93 are available at a global area. If you take local space, in the sense after allocation, 14 will be there with the process 1 and 81 will be there with the process 2. You can take only the replacement will be happen only within 14, only within this 81. You are not supposed to go to other. For example, if a number of processes will be gets increased, this number also gets decreased here. Okay, for example, process P1 will be taken some 25 pages, need 25 pages, process P2 will be required some 35, process P3 will be required some 45, process P4 will be required some 20, process P5 will be required some 15, something like this. All these things will be there. Identify the capital S value and allocate as far as proportional ratio. Now allocated number of things will be gets reduced here, completely reduced here. Okay, so therefore, if you, for example, it may be taken some 15, it may be taken no, not 15 exactly, it may be taken some 9, it may be taken some 6 or 8, it may be taken some 5, it may be taken from some 12, it may be taken from some 17. For example, these are the allocations. I did not calculate anything here. These are the allocation of frames which were done with the proportional. For example, local will be 9 will be local to P1. 8 will be local to P2, 5 will be local to P3, and so on, and so on. So therefore, if you are supposed to, when page fault is occurred, if you are supposed to access the things, you may be always looking forward for only these allocated things, which are locally allocated things. So this is obsolete. It is not supposed to be done. So that is why allocation of frames will be done at global. All the frames are available at global only. All the frames are available at global only. 93 out of 93 as far as our example is concerned. So 93 is 93 out of 93 will be available at the global. Now allocation could be done allocation does means, what do you mean by allocation here is when pace fault will be, when pace fault will be occurred I'm talking about this global here. When pace fault will be gets occurred, then allocation could be done based on the priority of the job. Priority of the job. If highest priority will be there, highest priority job is having a pace fault, then no frame is available. If no frame is available, then from lowest prioritized job, jobs frame will be forcibly deallocated and allocates to highest prioritized job. So it will be done. Allocation will be based on the priority of the job. If any highest priority job is having pace fault, then there is no frame which is available at a global place. Then from lowest prioritized jobs frame will be forcibly deallocated and allocated to the highest prioritized job here. This is being done. Okay. So in this way, the allocations are being available. In this way, the allocations are being available. These are the different kinds of frame allocation algorithms which are available with you. And so this will be asked to you for 7 marks. Okay, na?
Okay, sir.
Yeah.
Yes, sir.
Yeah.